The case for rapamycin, tripling lifespan and the urgency of anti-aging intervention. Seth Godin's quote, "If you wait until you are ready, it is almost certainly too late," resonates deeply when applied to the concept of aging and the pursuit of longevity. Time waits for no one. And as we stand on the precipice of groundbreaking discoveries in anti-aging science, hesitation may cost us the most valuable resource of all, time itself. One particularly astonishing discovery lies in the effects of rapamycin, Sirolimus, an mTOR inhibitor, on lifespan. In a specific strain of short-lived mutant mice, rapamycin extended their maximum lifespan by nearly threefold. This result is nothing short of extraordinary, suggesting that rapamycin doesn't just add a few years but has the potential to multiply life expectancy significantly. In normal mice and other species such as yeast, worms, and flies, rapamycin has also shown life-extending effects, albeit to a lesser degree. Additionally, it prevents or delays age-related diseases in mammals, including rodents, dogs, non-human primates, and even humans. Rapamycin and its analog everolimus are not experimental compounds on the fringes of science. They are FDA-approved drugs that have been safely used in humans for decades, primarily for preventing organ rejection in transplant patients. However, their potential to slow aging has been recognized since at least 2006, when it was proposed that rapamycin could be used as an anti-aging drug today. Despite this, more than a decade has passed, and widespread adoption of rapamycin for longevity purposes remains distant. The question now becomes, why are we waiting? The science of tripling lifespan. A closer look at mTOR inhibition. The nearly threefold increase in lifespan observed in mutant mice treated with rapamycin is one of the most dramatic results ever seen in the field of longevity research. This discovery has generated excitement because mTOR inhibition doesn't merely slow the rate of aging. It seems to fundamentally alter how the body ages. The mTOR, mechanistic target of rapamycin, pathway is a central regulator of cell growth, metabolism, and protein synthesis. Inhibiting this pathway appears to shift the body from a state of growth and reproduction to a state of repair and maintenance, thus slowing the deterioration that comes with aging. While these results are remarkable in mutant mice, the broader implications for human lifespan are still speculative. Even if rapamycin could only extend human life by a fraction of what was observed in these animals, the potential would still be profound. For instance, if rapamycin could increase human life expectancy by even 30%, a far more modest estimate than the tripling observed in mice, it would still represent an enormous leap in public health, adding decades of high-quality life. Human lifespan versus potential longevity. Currently, the average global human lifespan hovers around 72 years, with life expectancy in developed countries often reaching into the 80s. Despite modern medical advances, the upper limit of human lifespan, usually pegged at around 115 years, has been stubbornly resistant to change. But what if rapamycin could push that boundary? Let's consider the possibility of increasing human lifespan by a factor of 3. If an individual's maximum life expectancy were extended from 115 years to nearly 350 years, the social, ethical, and economic implications would be staggering. Would our institutions, social systems, and economies be equipped to handle such dramatic changes? More importantly, would the quality of life during those additional years be worth living? While such a tripling of human lifespan may still sound far-fetched, It forces us to confront an essential question. Why are we content to age and die at the current rates when science shows us that it may not be necessary? Rapamycin may not make us live to 350, but its ability to delay aging and improve health span, how long we live in good health, is already well documented. The urgency of action, overcoming fear and hesitation. If rapamycin is already FDA approved and has been used safely for years, why has it not become a widely accepted treatment for aging? The answer lies in a mix of fear, uncertainty, and a societal hesitation to view aging as a condition that can be treated rather than an inevitable process. The hesitation also stems from the regulatory and ethical hurdles that often slow the adoption of new medical uses for existing drugs. However, just as Seth Godin reminds us, waiting for the right time may result in missed opportunities. As aging continues, the irreversible damage it inflicts on the body accumulates, making intervention more challenging as time goes on. In this context, waiting until rapamycin's anti-aging properties are universally accepted and perfectly understood may mean that many of us will miss out on its benefits entirely. Rapamycin side effects, such as mild immunosuppression, are often manageable and reversible, especially when compared to the inevitable, irreversible consequences of aging, cancer, cardiovascular disease, cognitive decline, and death. The choice between manageable side effects and the harsh realities of age-related degeneration seems clear. The future of longevity. Embracing the potential of rapamycin. The potential for rapamycin to extend human lifespan by a significant margin is no longer science fiction. It's a scientific reality that has been demonstrated across various species, including humans. While we may not yet fully understand the limits of rapamycin's capabilities in human longevity, we do know this. Aging is the single largest risk factor for nearly every chronic disease that kills us. Addressing aging itself, rather than just its associated diseases, could be the key to unlocking unprecedented health and longevity. Waiting until we are ready for this shift in thinking may be too late for many of us. Rapamycin and its analogs are available now, and they have the potential to improve the quality of life in ways that modern medicine has yet to fully embrace. The time is now to push forward in the research and application of these drugs for longevity. In conclusion, rapamycin's ability to extend lifespan by as much as threefold in certain cases challenges our current understanding of aging and longevity. Its proven safety profile, combined with its capacity to prevent age-related diseases, makes it an incredibly promising candidate for anti-aging therapy. We must overcome the hesitation and fear surrounding its use. As the alternative, waiting until aging takes its irreversible toll will leave us with far fewer options. The future of longevity is within our reach, and rapamycin may just be the key to unlocking it.